Alright, students, we're going to do graphing inequalities now. When you graph inequalities, very similar to graphing a line. I'll get down some equations. I've got y is greater than or equal to negative 2 over 3x plus 4. And then I'll graph a second one on a different grid here. Y is less than positive 3 over 2x minus 2. Alright, so I've got my two graphs. You're going to identify slope and intercept point just like you would any other graph. Remember that y is equal to mx plus b. It doesn't change anything when you've got an inequality symbol. This is still your slope. This is still your y-intercept for this top one. So when I go to graph, I'm still going to use that same piece of information, those same two pieces, to graph my line. So my intercept point is 0, 4. That's going to be my first point. I'll put it right up here, 0, 1, 2, 3, 4. And then my slope is negative 2 over 3. So 2 down, 3 over. 2 down, 3 over. 2 down, 3 over. Alright. And now I'm going to draw my line. Now with inequalities, there are special rules about drawing the line. This one, y is greater than or equal to this line. So the line is included in your answer. You can be on the line and it's okay. For this reason, we're going to make the line solid. This signifies the fact that you can be on the line and it's okay, because the line is solid, and we all know if something is solid, you can be on it. Boom. Solid line, ready to go. So now that we've got our line drawn, we're going to shade. Now there are two ways to do it. There's a test point method and then my method. I'm going to show you my method out. You'll learn the test point method in class. I don't particularly care for it because it's very time consuming. But you've got your line. You're looking at y. Y is greater than or equal to the line. I'm going to read that one more time. Y is greater than or equal to the line. This means we want y, this line, and all the points above it, because we want y to be greater than this line. One more time. Y needs to be greater than the line. Since it needs to be greater than, we want to go up. Put your pencil, or pen in this case, on the line and go up in any direction. I'm going up. And you will shade where that arrow points. Greater than the line. We shade up. And that works on every line with the exception of the vertical lines. And I will show you those when we get there. So that's our first one. Our second one, you have y is less than. Notice there is no equal to sign for the second one. Very important notice, because y cannot be on the line and be true. We're going to signify this by using a dashed line. And I'll write it down for you here in a second, which ones are dashed, which ones are dotted. So I'm going to identify again my slope and my y-intercept. So slope is 3 over 2. Y-intercept is 0, negative 2. Take into account that minus. So I've got 0, negative 2. My slope is up 3 over 2. Up 3 over 2. Up 3 over 2. 4 dots for this one. And we are going to dash the line. Again, we are dashing the line because y cannot be on the line and be true. Y must be less than this line. So to give you it all written down, when you see these equivalency bars, this is when you have a solid line. When you see no equivalency bar, when it's just this, you will see a dotted line. And again, the reasoning behind that, solid lines mean y can be the line and it's okay. That's what the equal sign underneath your inequality symbol means. It can be equal to this, and that's okay too. If there is no equal sign, it cannot be equal to the line. It is not okay to be on the line. So we use the dotted line to signify this. Alright, now we're going to shade. Again, y is less than this line. Y is less than this line. I want all the points that are lower or less than this line. So I take my pencil or pen, put it on the line, and go down. Less than. Shade in that area. That's it. Again, there is a test point method. Your teacher will show it to you in class. I will show it to my class. But I prefer this way because it's is much less likely you will make an error in your directional shading. Let's do one where we have to move some things around, because with inequalities there are some very specific things that you have to watch out for. So I'm going to take 3x minus 2y is greater than or equal to 6. Here's my little graph. Going to get it ready to go. So just like any other line, I want to solve for y, get it in y equals mx plus b form so I can get the information I require to graph it. So I'm going to move this 3x first. Kind of get it to the other side of the equation. Subtract it from both sides. When I rewrite my equation, you'll notice I put x closer to my inequality, so it's in the same place every time. Y is now greater than or equal to negative 3x plus 6. Here comes the watch out for this point. All right? Be very careful. We are dividing by negative 2. All right? When you divide or multiply by a negative number with an inequality, the inequality will reverse. And there are many reasons it's going to happen like this. I can show you. In fact, I will show you real quick. Let's say that negative x was greater than 3. All right? I'm going to divide by negative 1 and not flip it. So now x is going to be greater than negative 3. So if we put in numbers into this first equation, let's pick, I don't know, 12. So I picked x equal to 12, and I'll notice that it's not true in this case. This is not true. Negative 12 is not greater than 3. However, if I put 12 into this equation, 12 is greater than negative 3. So right here, this is a counterexample that if you don't flip it, it's wrong. Notice if I do flip it, it's wrong in both instances. 12 is not greater, negative 12 is not greater than 3, and 12 is not greater than negative 3. It's not less than negative 3. I apologize. So there's a counterexample to it. Anyway, must flip the sign. So whenever you see this, you divide by a negative number. Notice I didn't flip it when I subtracted. Subtraction, not important. Division and multiplication, only times where it's important. Only time. Must flip the sign. Y is now less than or equal to 3 over 2x minus 3. 3 over 2x minus 3. From here, I just have to graph. This is my slope. This is my y-intercept. So 0, negative 3 is my first point. And then my slope is 3 over 2. So 3 up, 2 over, 3 up, 2 over, 3 up, 2 over. And I'm going to use a solid line. I've got an equivalency bar. So y can be on this line. And last thing, y is less than this line. Y is less than this line. So I'm going to take my pencil, put it anywhere on the line, and go down. I want less than this line. There's my shading. You guys will, of course, do a much better shading than I do, but that is how we graph inequalities. Remember to flip the sign. Lots of reasons. I could show you many different algebraic reasons that the sign has to flip, but just remember, when you divide or multiply by a negative number, you must flip that sign in order for your answer to remain accurate.